Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob!
I was gonna position them and then, you know, do the whole thing, but I think I'm just gonna place them where they're gonna go and then just solder them in place. In worst case scenario, I just cut them over here and then I use the other thicker, malleable cable. But I didn't want to do that since these cables are already, you know, placed. Problem is, it's so difficult because their cables are so small. Oh no! The worst thing that could have happened. Oh, this thing doesn't let me see. Now I just need to do the other side. God damn, Ray. God damn, Ray is hard. Very difficult. I didn't want to do this because it might burn my fingers, but whatever. Fa. Let me use a metal piece. Fingers crossed. I don't know if we're able to see anything, but come on, work, 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 work. Moment of truth. Moment of truth. Let's go! Nice, guys, we did it. Woo. I'm really happy about this. Yep. Let's finish assembling this so I can go to sleep. Guys, so I'm gonna put this right here, but to be able to do that, I need to unmount a little bit the motor, put the spring between the two parts, plug it back in, and then screw it back in. But before I do that, I wanna put the string on this part, which is gonna be what houses the string, and it's gonna be nylon, like I said. Let me do that first. Let me just tie it, and then, yeah, we'll go from there. I cut around 20 feet of nylon string. But yeah, hopefully this is easier said than done. Come on, baby, come out. Awesome, guys. It should be. So I just turn on the motor. Let me see. So this is the motor. It's gonna turn on, but it's not gonna engage with this part. It's just gonna be spinning by itself. But if I press this, there you go. Oh crap! Hold on, stop. Stop. So it worked, but it didn't work. So we're gonna give it some pre-wiring. Honestly, guys, I don't know what the hell I'm doing. We're just gonna do it.
Okay.
You can't see it, but it's pulling the string right now. I hope you guys can see it. I'm gonna unengage it, turn it off. Okay, it looks like it worked. Look, guys. Wow. Alright, let's keep going. It's not engaged, and then you engage it. That's so cool. It's gonna take forever, but come on. Alright. It's mostly on the right side. That's okay. I hope you guys can hear it too. That'd be cool. That's so cool. Looks good so far. That's so cool. Last but not least, the bullet. Like I said, the bullet has a bolt, a big nut, and then this one. So we're gonna tie it right here. Oh my god, I'm so tired. It's 2 a.m. in the morning. Is this gonna be worth it? Probably not. But it's worth it for you, the viewer. Even though you can't really see that much. Oh yeah, you can. Nice. Yeah, it's because the camera's kind of high up and I'm sitting down and it's hard to know if you guys are able to see. Yep. That's it. And this string, the nylon string, it's like different than normal string. It's kind of hard to tie. Oh no, I lost it. Alright. Calm and patient wins the race. There you go. Last but not least, we attach to the bullet. And then, now lastly, we get some of our magnets. And then we attach it right here. It's gonna be right here. So the idea is, whenever you wanna glue anything, you wanna make some small ridges to the thing. The reason why you wanna do this is so the glue sort of attaches better to the magnet. Because if it's a smooth surface, it's harder for the glue to grab onto the ridges and everything. So we're just gonna grab the glue that's all the way on the floor over there. Look.
A few moments later.
Just gonna grab the glue. And then we're just gonna drop it. And just because I'm impatient, I don't want to hold it, I'm just going to do this and hopefully it doesn't glue to the vise. Awesome, the whole setup is ready. I'll show you guys tomorrow how it looks, how it shoots, and hope you guys have a good night. If you're watching this at night or if you're watching this in the morning, have a good day. Bye. Hey guys, so let's go ahead and turn it on so it looks cool. And then this is going to be the first attempt with no string. Nice. I don't know if you were able to see it, but it shot pretty well. Now let's give it a second attempt with the string attached to it. As you can see, the string is attached, but there's a lot of friction within the small wheel right here. So even like free loose right now, I should be able to pull it, but there's a lot of tension. Let's try to open it. So yeah, I mean, fortunately and unfortunately, it sort of works how intended, but since this wheel is too, I guess, too small, there's a lot of like tension here and there's some like friction here as well. and the path as well, and like, you know, it's a little bit of a mess. I mean, it does reel it back in. I don't know if you can see it hanging. I'm gonna turn it on. So right now the motor's not engaged, but if I press this, it'll start engaging it, pulling it up. But yeah, long story short, I'm gonna redesign the bottom part just so we can have like a bigger wheel. Try to see if we could speed up that process and have less friction. And yeah, unfortunately it's gonna make it a little bit bigger, but at the same time, you know, in engineering you either go for like looks or functionality, and I think I'm gonna go with functionality. I want it to work, so it'd be pretty cool. But yeah. Hey guys, going back to the drawing board. So my idea for fixing the speed and the pulling of the string and like the whole like friction and stuff that doesn't allow us to shoot, and there's like some other issues. It's a little bit more complicated than I wanted it to be, but essentially right here we have the motor, which like lays right here, right? I'm trying to put it back in real quick. And so the rotation of axis is right here on this one, but I want to switch it from this axis to this axis. And the reason for that is because I want to include like a wheel. If you see the web shooter right here, I want to include like a circular wheel right here. And for it to twist this way, the axis of rotation has to go from here to here. So this is what I came up with. This part essentially mimics this, so I just didn't want to print the whole thing. And I printed a new attachment for the motor. And in theory, we changed the rotation axis from here to here. I'm gonna go ahead and try to turn it on. So there you go. It's kind of tricky with one hand. So yeah, essentially, it's gonna be connected right there, and the gears are gonna turn. It's still a little bit finicky. I need to polish some of the parts and stuff. And when I say polish, I mean literally in the CAD, like polish up the design, not really physically. But I mean, that's the idea. And I'll put a couple pictures showing how it would look. And here we are. This is the new prototype. I'm not even quite sure what prototype number it is. Maybe 7, I think, or 6, 7, 8. I don't know. And yeah, we'll go to printing. But yeah, we have the gears right here. We have a little cover for it, and we have the whole assembly of the main system. And then we have our big wheel, which is gonna house the string. More diameter means that it'll spin faster and it'll pull more string. That's the theory, but I guess we'll find out. So this is what we're looking at. It's still soldered into the old one, but I just wanted the motor because it's already connected and everything. Here are the gears that I showed you earlier, and then this is the thing that goes on top. Also has a gear thingy. This is gonna be housing the string. So let's try it out. So right now, this gear is connecting to all of those. It transforms from this axis to this axis. I mean, that's the theory, but you know. So. Cool. It's a little bit finicky, and then this cover allows it to sort of sit properly. And as you can see, it's semi-working. Yeah, it's doing a thing, but I mean, there's some issues here and there. I mean, this is not mounted properly. One of the main issues that I had was switching from that gear to like a bigger one, because obviously the teeth didn't match. And in the program you can make gears, but I was having some troubles with that, so we'll mess around with it some more and see what we end up doing. Here we go, here we are. This is the first version that I showed you guys, the one with the lights and everything, with the motor. Turns out works well. The issue with this one was the actual string thingy. It was too small. So this is like the second version from the final, I guess you could call it. And yeah, let me reassemble everything because I have some components here that were just placed quickly by some quick fixes just to see that it worked. But this time we're gonna assemble it properly. I guess let's begin.
Yeah, E minor, all right, yeah.
This piece did change. Same springs as before. I'm gonna put them right here. This one I just assembled it with some clips just to see that it worked. Let me show you. So right now it's rotating. This one was skipping because there was a cut right here. Whenever I would place the lock for the door, it sort of cut the red cable, and so that was not a good thing. So I'll be making sure to not do that again. Here's some of the samples for the bullets. This is the version of 5. It's the one with the magnet at the bottom. This one is the newest version. Never mind. This one is the newest version. The difference is that this one has a notch right here, so we could put the trigger mechanism. The hole used to be right here, but I switched it over here because once I placed it on here, on this piece, it would lock the whole mechanism except the bullet, and the bullet would be like freeform. But with this new method, I'm able to lock the actual bullet. So even if I go like this or like this, it's not gonna fall. So that's a new improvement for that one. I changed some cavities on the back so it's like smoother. You can also see the gears. They're just placed like that, so everything is gonna fall off. But right now I'm about to glue everything into actual place. I wanna make sure to not lose anything, because I mean I have extras, but I don't like losing them, you know. How long have we been working on this project, you're probably wondering, and the answer is like a week, and it's a long time. I have a bunch of different versions that I've been working on for this thing. This is version 8, I believe, and that's just the physical ones. For caddying in the software, I literally have like 100 versions, but that's just the gist of the whole thing. So the way that this works, essentially we have the motor right here, we have the gears which translate the axis like I showed you guys, right? And then it connects to this bottom gear right here, and that's what makes it twists. I ended up including a nut and a bolt right here because at some point for engaging the motor, I want to be able to press it down, and since it's like metal, it's less friction and it makes like a smoother rotation. Also right here, I increased the hole diameter so an actual spring can be placed in there, this one, and that allows us to have it always not engaged. So even if the motor is on right here, it twists the gears, but it's not twisting this thing until I press, I guess, the whole circle thing. This cover, you see that movement like from left to right? We don't want that, so with this little cap thing, it allows us to do it just like straight forward. I also included this, what would you call it? It's like a ridge or something. It's the same purpose, we don't want it to like do this motion, so I just included it. That way whenever you do press it, it's always like flat, even if you press it hard. So that's the reason for that. Everything else is from the previous design. We have the same mechanism from the springs. I mean, some changes here and there. I decreased the thickness or increased whatever. I made the hole for the cables bigger, so the cables wouldn't be so tight together. These holes for the batteries, I changed them slightly because they were not, I guess, concentric, you could say, with the actual physical battery, so that's gonna make it better. I made this thicker. You know how I did the little quick fix for this one, which was just including like a thin piece around it? I included it into the final version just so I don't have to like, you know, have so many pieces. What else did I change? The channel, instead of going from the center around, now I just have it straight through the side right here. The reason for that is because when I have the bullet placed, I want it to be pinching on the nylon string. So now it's going like from the side, so that's another change that I think will help it. Even this bolt, I made it a little bit up so it would grab into the motor a little bit better. And I think those were I changed some of the hinges spaces just so it would be a little bit tighter, because there was like a lot of movement, so right now there's like less movement. And like I said, I changed the hole from right here to right here. Those are the main changes. Let's get to it. Sorry for the yap, but if you guys are interested, now you know. Yeah, this is an M2 screw.
Nope.
So yeah, I need to get better with the names for you guys. This is an M2 bolt. I'll show you guys. The M just essentially says that it's in millimeters because you also have in inches, right? So M is for like metric, millimeters, and all that stuff. And 2 indicates the diameter for the actual, where the teeth are at. So 2 millimeters, and then you could say by the length. So for example, this is a M2 by, I want to say like 8 millimeters, but they vary in lengths. So a fun fact for you guys. I wonder how long this video is. It's probably gonna be long. I'm gonna try to cut it down though, because I know you guys don't want to watch as much of the assembly. You just want to see the results, I think. Maybe not. Comment down below if you like the process of the building, or if you like the results, or I don't know what you guys enjoy watching. For me, I enjoy the result as well. The cool thing about this disassembling thing is that I can just reuse it for the new one, so that's perfect because I don't want to have to do this resoldering thing. I do have to do the resoldering, but that's for the motor because the cable sort of broke on me. But this part, I can just carefully lift them up and the whole thing should come out. Just careful, SpongeBob, you don't want to break it.
SpongeBob, careful! Careful, SpongeBob! Careful, SpongeBob!
Here you go, you see? Cool, just like an assembly, just pop it back into the other one. Pop it back into the other one. What else do we need from this? For this one we need a Phillips. I wonder if this one will do the job. It sure will. Put this back. I like this tool, my dad gave it to me. It has a bunch of different heads that you can use for this. It's just a normal Phillips, but it's smaller than a regular, so this comes in handy.
A few moments later.
It's a long screw. There you go. Yeah, it's the one that we cut to size. This is the old one, we'll put it over here. This is the new one. I'm gonna go ahead and attach the back first. Also, I'm sort of sacrificing for you guys because having a camera and stuff in front of my face makes it 100% harder. I'm exaggerating, but usually I have like my stuff like very close to me so I could see it properly and everything. But for the camera view, you know. Oh, remember I told you guys I had to finish the other version so I could take it to my interview? I don't know if I did tell you, but I ended up taking it, and I mean, I didn't try out the strength for them because obviously I knew it wasn't 100%, but it was a work in progress, so I did like the lights, the actual shooting of the bullet, so that was cool. So there you go, we finally were able to get some of the teeth ingrained into the part, so now we can slowly but surely tie it together. Yeah, like I said, this is like 2mm, so it's nothing. Slowly but surely. Now we have to do another more side and we're good. It's fine, it's not that bad. This one will make it tight, but not too tight. There you go. Nice and snug, ain't it? Cool. Before we put the other one, just this one right here with the motor, I kind of want to disassemble it from here to see if I could solder the cables straight through. Let's do that. Yep. I like that my tube was black so I could see like the little screws because it's really difficult if the tube was like light color. So this is how the mechanism for the, I don't know if you can see it well. My camera doesn't have the autofocus thing. So this is how the mechanism looks on the inside for the switch for the motor. It's literally just the two holders for the battery, and then you have a switch which closes and opens the circuit, and you have a live, and then you have the ground which brings it all back together. So it's pretty simple. You literally give it power or turn off the power. If you want to rotate the other way, you're supposed to solder the cables backwards. Don't quote me on that, I'm pretty sure, but I don't know. Yeah, just by looking at them, I think we can solder them directly. This red one is right here. And the black one is soldered to this first little thingy. So I think we can just cut them and then solder the other cables directly. Instead of having to cut from here, from the actual cables and soldering to the cables, I'll do it directly to the part. I went ahead and set up everything for the soldering process. That's me. I'm gonna put some water into the sponge real quick. Now you're probably wondering, how am I gonna take the cables out of the thing? Honestly, I'm not quite sure. I'm thinking it's literally just heating it up and seeing if it's gonna come apart. Hopefully I don't get burnt. Let's try with the black one first. No, let's do the red one first. See if that works. No, I don't think it's gonna work. I'm just gonna cut them and then I'll set it up back again. Cool. So we went ahead and cut out the other cables, and I got some cables of my own. I'm gonna cut yay length, which should be enough. I hope. I think. The yellow is gonna be the black one. That's all we need to know. And then do about this much. Cool. Same thing for the black cable, which is yellow, but it's black for today. Cool stuff. Which one should we do first, guys? Place your bets. Dun, 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 dun. Okay, we're gonna do the yellow one first. Did you guess it right? Put down in the comments below. I'm thinking of doing like a little hook to it, maybe. Just like half hook. But pass it through somehow. Okay. So far so good. Sure, there's probably people in the comments, yeah, I could do a PCB with that, I could do it, and you don't have to do all this soldering, like, you can send it and they give it to you within days, and it's like $2, but that's not me. I don't know how to do that. Should I learn how to do that? Probably. Oh, I didn't think about the cable being on my way. Chat, we're gonna have to do it again.
Oh, brother, this guy stinks!
I don't know if you can see it, but this thing can sort of come out. I don't want to pull it fully because I don't want to break this little plastic pin, but it's far enough so we can do like a little loop first, stick it in, solder it, and then place the whole thing back. So that's what we're gonna do. Trick is doing the little loop small so it fits, but again, I don't know if you can see, but I just want to get this done. And then keep going here. Let's solder it right there. See if I can pinch it a little more. Perfect. Perfecto. Let's get to it. There's also proper ways to clean these. I don't know how, because I know there's also like some brush thing that you can like stuff your soldering iron into. But I'm not quite sure what the use of that is or why that's the case. Ooh, still a little bit hot. I wonder if I can take this whole thing out, because oh, I can't. No way, guys, no way. Look at this. So now I just need to clean this up, and then this is the old soldering. Obviously, I don't want to solder into it right now because I'm holding it, and I would burn my fingers for sure. So I'm just gonna try to cut my way through it. You know what? Whatever. Let's just feed it through, you know? There you go. You see? Fits perfect. It's perfect. A little bendy. Yeah, Mr. White. Yeah,
Yes,
science. Yeah, let's do this. F in the chat, let's just go for it, you know? Having a hard time. How many hours does it take an engineer to feed in a little cable? Actually, never mind. Ah! What am I doing wrong? Is this more down? the soldering iron's like in my face. I'm scared of burning myself. Unplugged it, put it to the side. Let's see. Why is your knife going? Copper is very conductible. It's one of the main materials used for conductivity. I'm gonna cut it, see what happens. Hopefully it doesn't come out apart. Right now I took off my goggles, and what I'm doing, I'm just closing my eyes when I cut the thing because it was flying. So I cut a good chunk of it. If I were to solder the thing again, it would come apart, but you know, it's fine. Honestly, this was supposed to be easier than soldering the cables, but shoot, it's a little harder. But in theory, it should work.